Hello, algebra students. Mr. Lawrence here, and today we are going to learn how to divide variables, namely like variables. And just like yesterday, we started off with whole numbers with exponents. We're going to do that today. Now, I know there is no way that I would ever raise 6 to the 5th power. That's a very large number. And then raise 6 to the 4th power, and then do the division. It's just too much work. I would much rather think about it like this. 6 to the 5th as the numerator of a fraction and 6 to the 4th as a denominator. Okay? And then I'm going to have 6 times 6 times 6 times 6 times 6. And 6 to the 4th is like this. Now, if I look here, I know that 6 divided by 6 cancels out into 1, right? And 6 divided by 6, those cancel into 1. And 6 divided by 6 there, they cancel to 1. These two 6's cancel to 1. And so what I really have in my numerator, get rid of that shade, is I have 1 times 1 times 1 times 1 times 6. In the denominator, it's all 1's, so it doesn't do any good to even write it down. And that'll simplify to all plain old 6. Okay? Or you might think about it as 6 to the 1st power. Okay? Now come down here and look at this x to the 8th divided by x to the 6th. Well, x to the 8th over x to the 6th, that's going to be 8x's in my numerator and 6x's in my denominator, right? And then I can do some canceling. Those will cancel to 1, those will cancel to 1, cancel, 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 cancel. What's left? X times x. Well, x times x is simply x squared. Now, check this out here. I had a 5 and a 4, and the bases matched, didn't they? They were both 6. And I end up with 6 to the 1st power, or better yet, just 6. Here I have like bases of 8 of x, an 8, a 6, a 2. 8 minus 6 is 2. When I divide like bases, I subtract the exponents. When I divide like bases, I subtract the exponents. Did you write that down? When I divide like bases, I subtract the exponents. Yesterday I was multiplying like bases, and so I added the exponents. Division is an inverse of multiplication, so I'm using the inverse of addition, subtraction. All right, now it gets a little bit different when you have a situation like this. Okay, 12 cubed divided by 12 to the 5th. So we're going to talk about that in just a minute. What I'd like you to do here, oops, left those answers there. Sorry about that. I would like you to pause the video and see if you can do problems 1, 2, and 3. Okay. Hopefully you've given them a try now, and you want to know that the first answer ends up being x to the 4th because I'm dividing. There's my division right there. Like bases, namely x. I subtract the exponents. 10 minus 6 is 4. Problem number 2. I've got like bases. It's division. I'll subtract x to the 5th power. Problem number 3. Like bases. Division. Subtract the exponent x cubed. Okay. Now, let's talk about that 12 to the 3rd divided by 12 to the 5th. Now, right off the top of your head, you're probably going to say, well, that's the same as 12 to the negative 2nd. But you probably don't know what 12 to the negative 2nd is. I'll give you a hint. The negative exponent will not make the number negative. The negative exponent will not make the number negative. The negative exponent will not make the number negative. The negative exponent will not make the number negative. Did you hear that, Mr. Smith? The negative exponent will not make the number negative. Okay, watch what's happened. Let's use my numerator denominator thing. My numerator is going to be 12 times 12 times 12, right? My denominator will have 5 12s being multiplied. Okay, and so we're going to cancel, we're going to cancel, we're going to cancel. My numerator will be left with a 1 because, when I divide 12 divided by 12, I get 1, not 0. So my numerator is 1. Now in the denominator, I have 12 times 12, or 12 squared. Okay, 12 squared is really gross, 144. Okay, so the best answer up here for 12 to the negative second is 1 over 144. That negative exponent sends the base to the denominator. If he were in the denominator, it would send him to the numerator. In other words, I use the reciprocal. All right, so let's see how that works. Okay, 2 to the fourth is 2 times 2 times 2 times 2, right? And that is going to be 16. 2 to the third, there's 1 less 2. That'll be 8. 2 to the second is 4. 2 to the first is 2. Now, before you try to answer 2 to the 0 power, ask yourself, how do I move down this column? Well, don't I divide by 2 each time? Right? So, if I'm going to go from 2 to the first to 0, I have to divide by 2. What's 2 divided by 2? Isn't that 1? Yeah, 2 to the 0 power is 1. Don't believe me? Punch it in the calculator. All right, now to move from 2 to the 0 to 2 to the negative first, I have to divide by 2. Well, wouldn't that be 1 over 2? Isn't that 1 divided by 2? So 2 to the negative first is 1/2. Hey, check this out. Check this out. 2 to the first is 2. And 2 to the negative first is 1/2. Oh, did you notice that? 2, 1/2. Well, 2 to the negative second is going to be 1/2 divided by 2. Well, that would be the same as 1/2 times 1/2, right? Or 1/4. So 2 to the second, 2 to the second is 4, but 2 to the negative second is 1/4. Ooh, I think I'm seeing something here. 2 to the third is 8. 2 to the negative third must be 1 over 8. 2 to the fourth was 16. 2 to the negative fourth must be 1 over 16. So you see I use the reciprocal. When I have a negative exponent, I use the reciprocal. So let's bounce back over here and look at x to the 10th divided by x to the 15th. Well, I've got like bases. They're being divided. I'm going to subtract my exponents to get x to the negative 5th. But since there's a negative exponent, I'm going to use the reciprocal 1 over x to the 5th. And notice the exponent changes signs. All right, there's 3 sample problems I want you to try on your own. I'll move that up in a second. We'll call them problems 4, 5, and 6. Try them on your own. Do them piecemeal just like we did the multiplication. Do your coefficients, do your x's, do your y's, do your z's, and you should not have a difficult time with this. Okay, if you're still watching, I assume you want to see number 4 solution. 24 divided by 2 is 12. X to the 10th divided by x to the 6th. Well, that's x to the 4th. 10 minus 6 is 4. Y to the 5th divided by y to the 4th. 5 minus 1. 5 minus 4 is 1. Plain old y. Excuse me. Z cubed divided by z cubed. Those are going to cancel out. They're going to turn into 1. I'm not going to write them in. Okay. You could do z is 0. Z cubed divided by z cubed could equal z to 0, but that's the same as 1. All right. Here's numbers 5 and 6. Why don't you see what you can do with those, and when you're ready, watch for my solution. If you're still watching, I assume you want to see my solution. I'll do 45 divided by 9. I'll get 5. I'll do x cubed divided by x squared. Well, that's plain old x. X to the first. Y to the seventh divided by y to the seventh. Those cancel each other out. Z to the sixth divided by z. Remember, it's like z to the first. That'll be z to the fifth power. Okay. Now here comes my solution for number 6. If you haven't tried it yet, pause the video, because here it comes. 100 divided by 20 is 5. X to the 12th divided by x to the 10th. 12 minus 10 is 2. Y to the 8th divided by y to the 5th. That's a y cubed. Z cubed divided by z. Remember, that's a z to the first. Z squared. And there you go. All right, that is your lesson for tonight. So now we know how to multiply like variables, and now we know how to divide like variables. Okay, tomorrow we'll raise some to powers. All right, Mr. Lawrence signing off. Have a good night, everybody. Hey.